the meaning of an electrical circuit and an electronic circuit. The electrical circuit is a path only to flow electrons from one point to other point. It's a path, an electrical path with wires in order to move electrons from this point through this point. This is an electrical circuit. And the flow of the electrons depends on yours if you open or close the breaker. This is the electrical circuit. The electronic circuit is more intelligent. You can program the electronic circuit, and the electronic circuit make decisions. That's the main difference between electrical circuit and electronic circuit. In digital, you have one socket for input power, input signals, and you have another socket for output signals. And the circuit board creates a path per each circuit. You have one path here for fuel, and you have other one for start, and you have other one for stop. This is an digital control box, and this is an analog control box. In digital circuits, you manipulate milliamps, microamps, milliohms, microamps. In analog circuits, you manipulate amps, kiloamps, kiloohms, high voltage, low voltage, high amps, low amps, high resistance, low resistance. For that reason, this is electronics, microcurrents, micro voltage, microamps. Small currents in electronic circuits, higher currents in electrical circuits. What happened internally in the relay? Normally, the terminal A, the bus of the terminal A is a copper metal, and the terminal B, they are separated. But in between both of them, there is a piece of ferrous alloy, steel or alloy, or ferrous alloy. That piece of metal in between this terminal and this terminal is surrounded by a coil. The beginning and the end of the coil are those terminals. When you powered that coil, the iron becomes a magnet and goes down and close the gap between A and B. When you remove the power on the signal, the magnetic properties on the iron disappear and the iron separate, and A and B is separated. I have a good example in this board that I prepared for use. I have the start relay. That's the input. This is the output. In this moment is open. In this moment, if I check with the probe, I have power here. I have power here. The light is on, but I don't have power here. When I send the signal positive and negative, that's the positive. Right now I send the signal here. I have power on the signal, and of course I have power in the output, and of course the light is on. How this relay works? This relay have this is the coil. The nomenclature said for the coil, the number for those terminals is 85 and 86. 85 and 86 for the coil. And this is the signal, the input signal that I wanted, that signal. And this one on top should be the output signal that I wanted to send. In between this terminal and this terminal on top, in between this terminal and this terminal, the connection is normally open. When I don't have power in between 85 and 86, those terminals are open. When I power it, those terminals close and the light is on. In this board, the input signal, the signal in the terminal 30, the input signal is coming from this positive common bus bar. And we have two signals, one in the middle. The connection in between 30 and 87A in the middle is normally closed. And the connection in between 30 and 87 outside is normally open. Okay, in this moment, the switch, this is the switch for the power in the coil, this is the negative, and this is the positive. Okay, in this moment the switch is off. No power on the coil. Okay, we are going to check what happened in the external. When I don't have power in the coil, that connection is normally open. Okay, in this moment I don't have power. That connection, the external, is the red one. The middle one is the green. Okay, in the external, right now I don't have power in the coil. The connection is off. When I power it the coil, immediately the connection in between 30 and 87 is on and the light is on. The solenoid is basically a relay, but in the moment that the connection between A and B is closed because the signal enter here, when the connection closed, when the gap in between A and B closed, additionally an external movement is produced. What is the function of the relay in a typical marine installation? For what reason you need the relay? You need the relay to avoid that you have power constantly in this point. Remember, what happened in a typical boat for the location of the engines between the starboard engine and the port engine. Normally in a typical boat you have a small space in between the starboard engine and the port engine. You practically have a space to pass one person in between both engines. And where is located the start motor in each engine? In between the transmission and the engine, in the bottom of the engine. If you are working in other equipment, air conditioning equipment, or installing a bilge pumps, and you have tools in your pocket like this, and you don't have relays like this, you have constant power in this terminal. If you are working and you approximate the tool to this point, you can produce a short, you can produce a spark, and you can produce an explosion. In other words, this equipment, the relay, is installed in order to avoid constant power in this terminal. The solenoids can be used in other type of application like this. This is a solenoid. When the solenoid is powered, positive and negative, immediately the plunger closes the valve. This is a solenoid valve to control the movement of the fluid. What type of fluid? Water, gasoline, diesel, gas, alcohol, any type of fluid. The fluid can be controlled. The fluid enter here and continue over there. You see the shape of that valve. Okay, when the plunger is off, the valve is open and the fluid pass. When you activate the coil, the window close and the fluid no pass. This is a typical solenoid valve or shut-off valve. The time delay relay is a regular relay with a time delay system incorporated internally. What is the function of the time delay? The time relay is a relay that can control the output signal. You can program the output signal to start each 2 hours during 20 seconds and stop again. This one is the regular bus relay. This one, the input is the 30. The output, there are 2 outputs. One output in 87, normally open, between 30 and 87 normally open connection. In between 30 and 87A, normally closed connection, and this is the output. This is the typical bus relay. What happened in this relay? I only administrate one signal. The input signal is here and you have 2 options. One option for normally open or other option for normally closed. But what happened if I have a relay that I can introduce 3 different signals in order to send 3 different signals? For example, like this. Look, this is 85 and 86. This is the coil. This is the common 30, 30, and 30. The same like this, 30. And this is 87A, 87A, 87A for this column, and 87, 87, 87. In other words, I can send through this signal, I can put here 6 volts DC. And I am going to use the output here, 6 volts DC. And I wanted to send through this one in the normally closed position 20 volts AC. And here 20 volts AC. And I wanted to send in this one ground. And I send the ground here. In other words, when I bring the power 85 and 86 in those terminals, I send 3 different signals. This is a multiple function relay.